In 1956, macroeconomic theory received its foundational blueprint, the Solow growth model. Standard curriculum often presents this framework as a sudden, isolated discovery, a clean break from past economic thought. However, the historical record reveals a different process. Robert Solow acted as an intellectual engineer. He identified a disjointed array of pre-existing economic theories and forged them together to solve a specific systemic problem. This diagram is the Solow growth model. To understand how macro growth actually works, we must deconstruct this theoretical framework exactly as if it were a mechanical engine. By tracing the historical origin of each specific gear, loop, and motor, the abstract math translates into an intuitive, systems-level understanding of the economy. This intellectual supply chain forms the backbone of Solow's model, requiring 6 specific components. Every major gear and motor was carefully sourced from earlier economic thinkers. Solow built his model by integrating these components into a unified system. Before 1956, these individual concepts existed in academic isolation. They were separate tools used to answer separate questions. When previous economists tried to combine them, the resulting math failed to produce a stable prediction of long-term economic growth. Solow's task was to take these historically incompatible parts and assemble a functioning, stable machine where others had only found theoretical dead ends. The baseline chassis Solow inherited was the dynamic growth model developed by Roy Harrod and F.C. Domar. Their framework successfully demonstrated how aggregate savings drive capital accumulation over time. This diagram illustrates the fatal mathematical flaw embedded in their framework, the knife edge. The Harrod-Domar model relied on fixed coefficients, an assumption that capital and labor must always be used in a strict, unyielding ratio. Because of this rigidity, any slight deviation in savings or population causes the entire mathematical model to either explode into infinite expansion or crash into total collapse. This inherent mathematical instability created a pervasive paranoia within macroeconomics. Solow had to engineer a way out. Solow's primary mathematical objective was clear. He needed to eliminate the rigid instability of the Harrod-Domar chassis. This is the 1928 Cobb-Douglas production function. Solow sourced this to serve as his primary engine upgrade. He used this equation to replace fixed coefficients with smooth substitutability between capital and labor. If you lack machines, you can use more workers, and vice versa. Solow selected this specific equation because it was empirically plausible, consistent with decades of U.S. manufacturing data, and highly convenient for steady-state calculus. Allowing capital to substitute for labor instantly neutralized the knife-edge instability. With the central engine secured, the system required internal plumbing to run continuously without breaking down. Solow integrated the classical Keynesian savings investment identity to create the first internal mechanism, the capital accumulation loop. This diagram shows the continuous cycle. Savings feed into the system to grow the total capital stock, while depreciation constantly bleeds capital out as machines wear down over time. To regulate this loop, Solow added a second internal mechanism, neoclassical factor pricing. This mechanism creates mathematical balance by ensuring that capital and labor are paid exactly their marginal products. As capital becomes abundant, its return drops, slowing further accumulation. Together, these two mechanics create a self-regulating closed-loop system that prevents capital from pooling excessively or depleting unnaturally. A static, balanced loop is elegant, but a dynamic macroeconomic model requires external inputs to drive it forward over time. For the first external input, Solow looked to the classical Malthusian tradition to source motor 1, population growth. This mechanical schematic shows how Solow formalized population demographics as a separate multiplicative factor that continually drives the labor supply belt. He then bolted on motor 2, technological progress, a variable sourced from broad empirical observation of industrial output. Solow treated both of these trends as exogenous forces. He did not attempt to explain within the model why populations grow or why technology improves. He only mapped how they drive the system from the outside. By treating these unpredictable real-world phenomena as predictable external motors, Solow kept the system mathematically tractable without losing its applicability to actual economies. We now have all the necessary historical components. The final step is assembling these isolated parts into a cohesive running machine. This matrix highlights the upgrade, replacing the rigid coefficients of the Herod-Donor model with the smooth substitutability of the Solow synthesis. This chart illustrates the result. Because of substitutability, if the economy deviates, internal mechanics naturally pull it back down to the bottom of the valley, settling into a stable equilibrium. The elegance of Solow's integration lies in mathematical compression. He compressed the Cobb-Douglas engine, the neoclassical pricing weights, and the exogenous motors into a single differential equation in intensive form. This master assembly finally gave macroeconomics a durable, solvable system. Once this mathematical machine is turned on, what does it actually output? This chart displays the model's definitive output, the convergence prediction. It identifies the steady state, notated as K star. This is the exact point where the required investment to equip new wreckers perfectly matches actual savings. Regardless of where an economy starts, whether it has abundant capital or almost none, the internal mechanics naturally drive it toward this specific equilibrium point. Establishing this predictable baseline allows economists to perform comparative statics, mathematically testing how changes in savings or population alter an economy's long-term trajectory. Discovering the steady state proved the machine worked. It gave policymakers a reliable mathematical target, permanently curing the knife-edge paranoia of the past. This diagram represents the fully assembled intellectual framework that Robert Solow built. His curation was exact. He forged a scattered set of historical theories into a coherent, empirically usable tool. By explicitly leaving the technological motor unexplained as an exogenous variable,